To this class again, science class. Today's chapter is chapter 9, grade for high school, grade 8, and it's a chemical reaction. So at the end of this chapter, you expected to learn, to revise what you know about physical and chemical changes. At the end of this chapter, one of the things we need to know is to revise what we have already studied earlier on regarding physical changes and chemical change. And then also at the end of this chapter, we are expected to also be able to describe chemical reaction. At the end of this chapter, we are also going to be able to describe chemical reaction. Yeah, at the end of this chapter, we should also be able to write word equations to show chemical reaction. We should be able to write word equation. And then at the end of this chapter, we should also be able to identify different kinds of chemical reaction. The different chemical reaction like thermal decomposition reaction, combustion reaction, all kinds of chemical reaction. At the end of this chapter, we should also be able to carry out an experiment to show chemical reaction. Simple and basic experiment to show chemical reaction. Okay, now first and foremost, let's take a look at chemical change and physical change. Let's take a look at these changes. Let's take a look at these changes that we call chemical change and physical change. Let's take a look at these changes that we call chemical change and physical change. Okay, first and foremost, when I'm burning a matches, is it a physical change or a chemical change? So we can tabulate them. We can draw a table and identify what is chemical change and physical change. Okay? What is chemical change and physical change? Chemical reaction is the type of reaction, first and foremost, where new products or new substances are formed. Okay? Where new products or new substances are formed. While physical reaction, you don't really have new substances. Okay? It's just a mixture. It's just a mixture of two or more things which can be physically separated by easy means can be separated. So chemical reaction is when elements or atoms combine together to form a new bond. When atoms combine together to form new bonds, first they do this by first of all breaking their old bond, or if they are compounds already, the bond that exists between one compound and another compound will be broken and new bonds will be formed. The old bonds will be broken. For example, if you say hydrochloric acid react with hydrochloric acid react with sodium hydroxide. You know, sodium hydroxide is a compound containing sodium and oxygen and hydrogen. Okay, it's a compound. Now, when it reacts with hydrochloric acid comprises of hydrogen and chlorine. So the bond in sodium, oxygen, and hydrogen will be broken, and the bonds in hydrogen and chlorine, which is hydrochloric acid, will be broken. New substances will be formed. New bonds will be formed. These type of reactions are termed chemical change. They are called chemical change. Okay, when new products are formed, even if you say like hydrogen react with oxygen to form water, for example. If you write this equation, hydrogen react with oxygen to form water. This type of reactions, they are called chemical change. They are called chemical change. Okay, new substances or new products are formed, and it's very difficult to go back. They are not easily reversible. It's very difficult to go back to get the constituent atoms that made up that change. But for physical change, you can easily go back and get the substances. Okay, so this is what we see. Now, when you burn a candle, it's a chemical change, right? When you burn a candle, it's a chemical change. You know why? The candle wax will melt and it's not easy to get back the candle, right? So when you burn a candle, it's a chemical change. Am I right? Hello? Are we right?
Yes.
Okay. So we say when we burn a candle, that's a chemical change. When we burn matches, we take a match stick and light it up and it burns to ashes. This is also a chemical change. This is also what? A chemical change. Is that okay? This is also a chemical change when we burn a matchstick, right?
Yes.
Okay. Then when we melt ice, is it a chemical change or a physical change?
Physical.
Physical. When you melt ice, is a physical change. When we melt ice, is a physical change, right? When sugar dissolves in water, is it physical or chemical change? Sugar dissolved in water.
Chemical.
No. It's a physical change. You can get sugar back. You can get the sugar back, right? So when sugar dissolved in water is a physical change. In chemical change, new products are formed, and it's very difficult to get back the old substances that form the product. Now let's take a look at them. We're going to look at what are we benchmarking with. We're going to look at what we're benchmarking with between physical and chemical change. First of all, we want to look at the composition of substance. We're looking at their composition. So when you look at their composition, what is physical substance or physical substance made up of? Physical change, what happens when you look in terms of the composition of substance? Now, physical change, the composition of each substance is not changed. So I will just write not changed. I will write not changed. The composition is not changed. But for physical, the composition will change. You understand what that means? For physical change, the composition of the substance do not change actually. Right? The composition do not change.
Yes.
The molecules are what they are. Okay? It's just that they may be a bit farther apart from each other, but the composition do not change. But for physical, new substances with different properties are formed. So here we say for chemical, we say new substances are formed. Here the composition changes. New substances will be formed completely. New substances will be formed. New substances will be formed. Okay? Then let's take a look at in terms of their properties. In terms of properties. Let's take a look at their difference in terms of properties. What are the properties in physical change, and what are the properties of a substance when a chemical change happens to it? In terms of property. So in terms of property, first of all, physical properties such as size, color, and state may change, but chemical properties are not changed. Say the physical one, like size, may change. Size, color may change. Like the size, like ice block may change its size to something else. So size may change, color may change, okay? Color may change, but the chemical property of that substance do not change. Size, color, all this one will change in physical change. In chemical physical properties are changed. In chemical change, both the chemical properties and so I will use C to represent chemical, CH to represent chemical chem. Okay, let's write chem. Both the chemical properties and the physical, PHY, both the chemical property and the physical properties will change, both of them. But in physical change, only the physical properties will change, but the chemical do not change. The chem not change. So the chem property will not change in physical change. So I write chem not. Chem not means chemical property will not change. Chem not means the chemical property will not change during the physical changes process. The chemical property of that, like the atomic structure, the molecules, the chemical properties of that substance during physical change will not change. But however, the physical property might change, like the size, the color, and so on and so forth might change. Now let's take a look at them in terms of nature of change. Nature. In terms of nature of change. In terms of nature, in terms of nature of change, okay? So we can be ruling them step by step. Okay, this one is waste of our writing space. No need to read. Okay. In terms of nature of change, then one, we will say that the physical case can easily be reversed. Original substance can be recovered from in a physical change. So you can say easily reversible. Easily reversible. Meaning, if you change ice to water, if you melt ice and it turns to water, you can easily get the ice back by freezing the water. Meaning you can easily reverse the process and get whatever you used to get the new substance by simply reversing the process. Okay, so easily reversed. Physical changes are easily reversed. I gave an example of ice, melting an ice. When you melt ice, you get water, and you can easily reverse the water back to ice by freezing it, right? By freezing it. Then for chemical change, not easily reversible, right? Not easily reversible. Some may be reversed by other chemical reactions, but not easily. So we say not easily reversible. Not easily reversible. So chemical change, we say not easily reversible for chemical change. Not easily reversible. For chemical change. Okay, then another in terms of the mass of the substance. Let's take a look at them in terms of mass. In terms of their mass. Let's compare them in terms of their mass, chemical change and physical change. For physical change, the mass of the individual substance at the end of the change is the same at the beginning. Mass is same for chemical change, just write same. At the beginning of the reaction and at the end of the reaction, the mass is same for chemical changes, right? For physical changes, for physical changes, the mass is same, both at the beginning and until the end, the mass is same. Then, for chemical change, individual masses of the substance, they will change, but the overall mass remains the same. Individual mass change, overall same. Individual, so I abbreviated individual mass same. We say individual mass will be same. Individual mass will be same. But overall mass will be different. Overall mass. No, wait, we are missing it up. We say the individual mass may change, but the overall mass will be same. It's the overall mass that's same. Overall mass, the overall mass is same. Overall mass is same. Overall mass is same. But the individual mass may change. So the individual mass may change. We can just cancel this, right? One strike. We write change on top. Individual mass may change. The individual mass of the substance may change, but the overall mass in chemical change, the overall mass will be the same. Okay, number, how many properties now? 1, 2, 3, 4. We've looked at 4 different properties. Now let's take a look at another property. Let's take a look at another property. This property will be the evolvement of heat. The evolvement of heat. So I'll write heat here. How much heat is found in both cases, physical change and chemical change. Now, only small amount of heat are needed for or are produced. Small heat small heat, small amount, okay, small amount of heat is needed. Is needed or is produced. Needed if the reaction is an endothermic reaction, and produced if the reaction is exothermic reaction. We're going to explain endo and exothermic reaction. Is needed or produced. You know, there are some cases, some reaction in which heat is produced to the surrounding, whereas there are some reaction that takes the heat in the surrounding and use it. So the one that takes heat from the surrounding and use it, they are called endothermic. Endothermic. The one that produce heat to the surrounding, they are called exothermic. They are called exothermic reaction. So we say for physical change, only small amount of heat is used, that's used from the surrounding or needed from the surrounding, or if the case is exothermic, or small amount of heat is produced, Whether it's used up or is produced, for physical change is just a small amount of heat. Whereas chemical change, large amount of heat may be needed or produced. So here, for chemical change, large heat is produced or needed. Large heat. For chemical change, large heat is produced. Yeah, because there is a chemical reaction taking place. Is produced or is used up. Used up means is needed. Okay, is produced large amount of heat because, for example, you are burning matchstick. Burning produces a lot of heat. So you can see the heat everywhere, or your burning bush. You see, you're giving a lot of heat, you're producing a lot of heat. If you go near it, or you're cooking in your kitchen, if you're cooking with your gas cooker, you're cooking food, if you go near it, you see everywhere is hot, producing a very large amount of heat. Probably chemical change is taking place. When you're burning bushes, chemical change is taking place. And large amount, this is a chemical reaction or chemical change is taking place, hence large amount of heat is produced. Also, when there is neutralization reactions and other reactions, large amount of heat is needed. So we say some reactions also take heat from the surrounding. So large amount of heat is produced or needed, or used or needed. So large amount of heat is produced in chemical change or needed. So anytime there is a chemical change, there is very large amount of heat that is produced or used or needed. Okay, so these are the 5 subheadings for comparing physical change and chemical change. We looked at them, first of all, in terms of composition. Okay, in terms of composition, we say physical change, they do not change. The molecules do not change. So you can write molecule here if you so wish. The molecules do not actually change, but they meaning they do not really form complete new substance. Not change, but for chemical change, new substances are produced. New substances are produced for chemical change. Now we look at them in terms of their properties. We say for physical change, both there will be a physical change for physical in the physical properties, like the size and color may change, but the chemical property of that physical composition will not change. Then in chemical change, both the physical and the chemical structure of the compound or of the molecule will change. So we can put change here. Both the physical and the chemical structure will change. Now, then number 3, in terms of the nature, we say the nature of the substance. We say in physical change, they are easily reversible. You can get back, like you melt ice, you can get back the ice. If you melt ice to water, you can get back the ice. But in chemical change, we say they are not easily reversible. They are not easily reversible. Even if you have to reverse them, this is not easy. Is that okay? They are not easily reversible. Can you hear? Hello? Hello? Can you hear? Hello? Hello? Okay. So we say in terms of nature, we say physical change are easily reversed, chemical change are not easily reversed. Then in terms of their mass, we say the mass is same, both at the beginning and the end, the mass is same. Then we say for chemical change, the individual mass, they are different, they change, but the overall mass will be same. Okay. Then we talk about their heat composition. We say for physical change, small heat is needed or produced. Then for chemical change, large heat is produced or is needed. Is that okay? So this is for looking at the difference of physical and chemical change. Now let's go to describing chemical reaction. Let's go to describing chemical reaction. Chemical reaction. Chemical reaction. So let's look at describing chemical reaction. Okay, in chemical change, remember, the substances that are involved in the change react with each other. They react with one another in some way. They kind of react with one another in some way. For example, if we take a look at example, then from your material, you see that the metal potassium reacts with a chemical in cold water to give out lots of heat and light. So in reaction, the atoms of each substance are separated and they're put together again in different ways. So we call this type of reaction chemical change or chemical reaction. We call it this type of reaction chemical reaction. The atoms of each substance are separated and then put together again to form a new product. Okay, for example, the atoms of this one, there are 2 atoms of hydrogen here. See, this is a molecule of hydrogen. This is 1 molecule of hydrogen, which comprises of 2 atoms of hydrogen, So these 2 atoms will be, the bond holding them will be broken. You know, there's a single bond holding these 2 atoms together. This bond will be broken. Okay, this hydrogen bond will be broken. Then plus water. Okay, plus oxygen. Plus oxygen. Oxygen is 1 atom of oxygen to another atom of oxygen is a double bond. It's double bonding. So this O2 you see is what we represent like this, and this H2 you see is what we represent like this. Okay, so they will break into this bond. First of all, this molecule will break into this this bond will be broken to each of these atoms. That's the first thing that happens in chemical reaction. First of all, it will break the bond between the molecules, or the bond between the atoms of the molecules. To break the bond of the atoms of the molecule, to break the bond of the atoms of the molecule, and a new bond or a new substance will be formed. Now this is the new substance that will be formed. A new bond or a new substance will be formed, which is H2O. A new bond or a new substance will be formed, which is H2O. So we can balance this reaction. We can balance this equation. We can balance this equation. So we can balance this equation. So how do we do that? We can balance this equation. So how do we do that? You see, we have 2 atoms of hydrogen here, 2 atoms of oxygen. So if I put 2 here, okay, let's use a different color to balance the equation. If I put 2 here, originally we have only 1 molecule of water. Now we have 2 molecules of water. Now we have 2 molecules of water. So since we have 2 molecules of water, and the hydrogen, how many atoms of hydrogen? Atoms of hydrogen will now be 2 multiplied by 2. We have 4 atoms of hydrogen here, and 2 times 1 is 2, 2 atoms of oxygen here. So I have to put 2 here to make hydrogen 4 as well. So 2 times 2 hydrogen is 4. Here, 2 times 2 hydrogen is 4 on the right. So oxygen is 2 because here, and oxygen is 2 here because this 2 multiplied by this one is 2. So this is what we call balance equation. There are 4 atoms of hydrogen here and 2 atoms of oxygen here. So this is what we have on the left, the reactant. This is called the reactant. In chemical reaction, we have the reactant, we have the product. So this is called the reactant. In the reactant side, you see 4 atoms of hydrogen, 2 atoms of oxygen. Here in the product side, you also have 4 atoms of hydrogen and 2 atoms of oxygen. 4 atoms of hydrogen and 2 atoms of oxygen. So you can see the equation is balanced. When you have this, then you say the equation is balanced. Okay? This is a chemical reaction. First of all, why is it a chemical reaction? The bond here, if you want to see the bond here, you see that this is a HO or OH bond. HO bond, single bond. But there are 2 of it. HO bond, but there are 2 of it. This is the bond here. Okay? Okay, so this is what we have in this reaction. You see a new substance is formed in chemical change, water. See, water is formed, a new substance is formed. And this is called the product. This is called the product. Okay, the product form is water. The reactants are hydrogen and oxygen. This is called the product, and the product is what? Water. The reactants are hydrogen and oxygen. Is that okay? So that's the first step. Now let's move on and look at it. Use the equation to describe the reactions. Use the equations to describe reaction like we have just done. We've just given you hydrogen react with oxygen to form water. But there's something else that is also formed, which we don't normally write. There's something else that is also formed. It's called heat. It's called heat energy. Okay, when this reaction happens, heat is produced. Heat energy is given to the surrounding. Heat is produced. Is that okay? So that means this reaction is giving heat to the surrounding. Is that okay? Now let's take a look at the group of atoms Okay, let's go to naming molecules. Let's go to naming molecules. Another subheading, naming molecules. Naming molecules. Okay, molecules I will just write. Okay, that's fine. Naming molecules. Okay, the name of compounds can tell us what elements that compound is made up of, right? And if you give a name to a compound, you can be able to tell which element is. For example, if I say hydrogen chloride, you already know hydrogen chlorine, right? So the name can tell you which element that is. Sodium hydroxide. Sodium hydroxide. Hydroxide you already know is OH. Then sodium is Na, so it's NaOH. So there's sodium, there's oxygen, there's hydrogen for sodium hydroxide. So the name of a compound can tell you which substance is the compound is made up of. When the name contains any of the group, you can work it out and find out which elements are found in that group of compound that has been given to you. For example, sodium nitrate. Okay, if you say sodium nitrate, now which elements are found in sodium nitrate? So sodium nitrate, let's write because we don't have enough writing ink to write it in words, so I write it in symbol. Sodium nitrate is NaNO3. This is sodium nitrate. So you can tell which elements are there. There is sodium, there is nitrogen, there is oxygen. So these are the elements that are found in sodium nitrate, right? These are the elements that are found in sodium nitrate. Aluminium hydroxide contains what? If I write aluminium hydroxide, aluminium hydroxide. Okay, if we say, let's say for example, if this is aluminium hydroxide, maybe there's 2 here, there's 3 here. If this is aluminium hydroxide, for example, which elements are there? There's aluminium there, there's oxygen there, there's hydrogen there. So you can easily tell which substance is for. You know how to write nitrate, sulfate. Sulfate is SO4. Trifate is SO3. Okay, so if they say potassium sulfate, potassium is K. So you can easily, like, there's potassium there, there's sulfur there, there's oxygen there, right? So in case they say potassium, if they say nitrate is NO3, so anything with nitrate, you can now, like barium nitrate, there's barium there, there's nitrogen there, there's oxygen there. Sodium nitrate, there's sodium there, there's nitrogen there, there's oxygen there. So if you give a compound, you can easily, from the name, you can tell the elements that compound is made up of. Okay, so easy for us to detect the element. For example, so hydrochloric acid contains what? If I say hydrochloric acid, if I write hydrochloric acid, it's just hydrogen and chlorine. Hydrochloric. So you see the name? Hydro, that's hydrogen. Chloric, that's chlorine. So hydrochloric acid is made up of hydrogen and chlorine. That's hydrogen. Hydrochloric, that's chloric, that's chlorine. So it's made up of hydrogen and chlorine. Hydrochloric acid is made up of hydrogen and chlorine. Is that okay? Now, we know this because names contain hydro and chlorine. How do we know this? We see hydro and chlorine. Hydro and chlorine. So anytime you see hyd, H-Y-D-R, anytime we see hyd like hydro, then the compound contains hydrogen. That's the meaning. When you see hyd, it means the compound contains what? Hydrogen. Let me just use symbol for hydrogen. The compound contains hydrogen. The compound contains hydrogen. Anytime you see hyd, the compound contains hydrogen. And it starts with hydrogen. Hydrochloric acid. Okay? when you see the compound contains hydrogen, for example, sodium hydroxide. Okay, if you see sodium hydroxide, sodium hydroxide is like this, NaOH. See? Sodium hydro. This hydro. After sodium, the metal, then there's hydroxide. Hydroxide is always OH. Hydroxide, when you see hydroxide, is OH. Okay, so that's for height. Now let's see chlor. Any compound that contains chloro. See? Chloro. The compound contains chlorine. Any compound that has this, it means it contains what? Chlorine. Means the compound contains chlorine. Like in the case of, for example, like in the case of silver chloride. Like in the case of silver chloride. Silver, the metal first. You know, we always name the metal first before non-metal. This chloro is non-metal. So when we say silver chloride, we're going to say AgCl. AgCl, probably too. Okay, this is silver chloride. So once you see chloro, the compound contains chlorine. Once you see chloro, the compound contains chlorine. What if you see ox? What if we see ox? Like oxide. Oxide. The compound contains oxygen. For example, copper oxide. Meaning the copper contains oxygen. A good example, once you see ox, like, for example, like copper oxide. Copper, Cu, the O. Copper oxide, okay? Because of the writing, I was supposed to be writing them in words. The board, we don't have enough space to write. Okay, so once you see like this, then this is a oxide. Copper oxide. It contains oxygen. Is that okay? What if we see sulfur? We see sulfur. If we see sulfur, it means it contains what? The compound contains sulfur. For example, sodium sulfate. If you see sulfur, the compound contains sulfur. A good example is sodium sulfate. Sodium sulfate. Sodium sulfate. Once you see sulfate. Sodium sulfate. It means the compound contains sulfur. So once you see sulfur, there's sulfur. Sulfate. Once you see sulfate, it's SO4. I already said that sulfate is SO4, trifate is SO3, right? Sulfate is SO4. We already said that earlier on. SO4. Trifate is NO3. Okay, now let's take a look at this one. Once we see, what if there is acid? The compound contains hydrogen, for example, nitric acid, sulfuric acid. Once you see acid, it means the compound contains hydrogen. Once you see acid, because there are some, they say, there are some, the name, you won't know what it contains, but they will just say, for example, they will say nitric acid, or you hear sulfuric acid. So once you see acid, it means the compound contains what? Hydrogen. Even if they don't measure hydrogen, they just say nitric acid. So you should know that the compound contains hydrogen. The compound contains hydrogen. A good example is nitric acid, meaning H. There's no way they measure H, but because you hear acid, you know there's H. HNO3, nitric acid. This is nitric acid. Like nitric is coming from nitrate, nitric acid. Because of the H, it's written like this. Then another one is sulfuric acid. They just say sulfuric. They didn't measure H, but because they say acid, sulfuric acid, you know, is H2SO4. H2SO4. Why is this one? Why is this one H2? Because this one has two minus. We'll talk about the valency later on. Talk about valency later on. Okay, so these are. Why you falling?
Not falling.
Okay, so this is nitric acid. This is sulfuric acid. So when you see acid, once you see acid, there's hydrogen. Compound has hydrogen. In fact, hydrogen begins the compound once you see acid. Is that okay? Okay, so that's that for some names that start with all these abbreviations that you need to get familiar with. We can also tell whether a compound is likely to contain any other element by looking at the name. If you look at the name, you can tell whether the compound contain any other element. Like for example, when the name of the compound ends with IDE. When the name of the compound ends with IDE. So when the name of the compound ends with IDE, for example, sodium chloride. You see the chloride, sodium chloride. This chloride, right, ends with IDE. Right, ends with IDE. Sodium chloride. So you know there is what? We say once you see this sodium chloride, iron sulfide. Okay? Iron sulfide. You see, they end with IDE. Iron sulfide, sodium chloride, iron sulfide. Then the compound usually contains only the two elements in its name. So once it ends with IDE, it contains only two elements in its name. Like sodium chloride, meaning it contains only sodium and chlorine. Once it ends with IDE, only sodium and chlorine. Iron sulfide, then it contains only iron and this sulfate. Is that okay? Now, when the name of the compound ends with ATE, when the name of the compound ends with ATE, like sulfate, when the name of the compound ends with ATE, then what do we have to show for that? Or what can we say about that? When the name of the compound ends with ATE, for example, like silver nitrate, sodium sulfate, silver is Ag, okay? Silver nitrate. See, silver nitrate ends with ATE. Okay? Like silver nitrate, and then like sodium sulfate, sodium sulfate, okay, you see they end with nitrate, sulfate, they end with ATE. So when you see this sodium sulfate, then the compound contains the element oxygen as well as the ones in the name. These ones, it means it contains oxygen. Okay, this one does not contain oxygen. Sorry about this one. Iron sulfide. Iron sulfide is just FeS. Okay? FeS. When it ends with IDE, it does not contain oxygen. But when it ends with ATE, the compound contain oxygen as well. So silver nitrate, there's silver, there's nitrogen, there's oxygen. Sodium sulfate, there's sodium, there's sulfur, there's oxygen. So any name that ends with ATE, it has those two elements plus oxygen together with it. But all the ones that ends with IDE only has those two elements that are found in it. Like sodium chloride is only sodium and chlorine. Iron sulfide is only iron and sulfur. Is that okay? For ATE, any name that ends with ATE, like silver nitrate, sodium sulfate. They have those two elements, silver and nitrogen, and then there's oxygen in addition to it. There's oxygen in addition to it. So this is where we stop for today's part 1 of this class. Then the next part 2 will be types of reaction. We'll be looking at the types of chemical reaction. We'll be treating the types of chemical reaction for part 2 of this one. Okay, thank you.